The title of my project was Building Applications in the Safe Network. The Safe Network is a decentralized data storage and communications network that provides a secure, efficient, and low-cost infrastructure for everyone. The Safe Network brings with it an entirely new way to build applications, in that for the first time ever, really, there's been a decentralized data storage platform where users ultimately own their own and control their own data. This is juxtaposed to a system like BitTorrent, which is also a data storage platform, but users don't really own their own data. So in BitTorrent, what happens is when you upload a file, it gets split into these small chunks. These small chunks are then seeked from other peers in what is known as a swarm. So you join the swarm and you say, hey, I want this chunk of data, that chunk of data, and the other node in the swarm will serve those chunks to you if they have them. The safe network is kind of similar in that data is broken down into 1 megabyte chunks before it's uploaded to the network. And these chunks of data are stored in what are called vaults. Now, vaults join together to form what is known as a section. A section is a group of vaults that are responsible for looking after a certain address range. So in the safe network, addresses are based on 256 bit addresses. So a given section is responsible for a certain portion of that. For instance, if there was two sections, one would be responsible for all addresses that start with 0, and the other section would be responsible for all addresses that start with 1. I'm talking binary here. What this means is that through different mechanisms, you can securely store data on the safe network for either private consumption or public consumption. So my application specifically looked at the public consumption of data. And to do that, what I did was create an application called SafeWiki that could facilitate the storage and browsing of ZIM files on the safe network. Now, a ZIM file is simply a file format that allows you to store content that comes from the web. The most popular usage of a ZIM file is to store websites like Wikipedia. So with the creation of my application called SafeWiki, it's possible to store archives of a website like Wikipedia on the safe network and then serve it to everyone. So I'll just show you how that works now. Here I've got 4 vaults running. So these vaults, as you can see, have started already to talk to each other and they are ready to serve data. So what we'll do is we'll open up the safe browser. So the safe browser is kind of your entry point to the safe network, and it's what allows you to log in to retrieve your data and also just to authenticate yourself with the network. So I'm just going to create just a fake account here. You see we're just registering here. If you go back over here, you'll see that one of the vaults is now managing a client account. So you can just see that we're now storing data. So I'll just allow that, and that's us now. So now we're actually authenticated with the safe network and we're ready to work. So what we'll do is we'll come over to SafeWiki and I'll show you how this works. So SafeWiki itself is actually based on an application called KiwiX. Now, KiwiX is a long-standing project that is dedicated to bringing educational content to the world. So whether this be you're in the middle of the Atlantic Ocean or in North Korea, with the use of these ZIM files, they are offline archives of websites like Wikipedia, so you can access these great resources without needing an internet connection. SafeWiki exploits this to use the safe network for the storage of these files. So let me just connect to the safe network. So you'll see waiting on safe network. Come over here, we'll click allow. So this is just authenticated the application to work with the safe network. So you can see we're now connected to the safe network. I'm now going to create what is known as a ZIM folder. Now, a ZIM folder is just a collection of these ZIM files, so it allows people to more easily find the location of them. So let me just create a ZIM folder. So now I've created a ZIM folder called Stack Overflow. So what I'm now going to do is upload a coffee ZIM file to the network. So this is literally an offline archive of the coffee Stack Overflow pages. So I'll just click upload, and you can see in the right hand side here the file has now been uploaded to the network. Okay, so I just made a little cut there while the file was uploading. If we go into the vaults now, you can see all of the requests and activity that the vaults have been going through as that file was put onto the network. So what we'll do now is we will go and log out of Ceph Authenticator and create an account. So this, I'm just doing this just so you can see that other users will be able to access the files that another user uploads to the network. Oops, daisy. There you go. Secure password, as you can see. So registering on the Ceph network, and there you go. So this is now an entirely new account on the Ceph network, so you'll notice that Ceph Wiki isn't here. So if we can back over to Ceph Wiki and go into Ceph network and you go connect to Ceph network. And there we go, we're authenticated. The one thing you will notice is that this Ceph Wiki instance doesn't have a Zim folder. So remember on the old one that we created a Stack Overflow Zim folder, well, this account doesn't actually have a Zim folder. So this is a representative of just an entirely new user logging onto the network and wanting to access that Zim file. So let's just type in the credentials here. So you'll notice the name we use for the collection is the name of the Zim folder. So in this case, Stack Overflow, and the file name, coffee, was the name of the Zim file that we uploaded. So on the right hand side of the page here, you can see all of the reads that are happening from the network. The first time that a page loads in, the first time you open a Zim file, it actually is a little slower than subsequent page loads. This is because the very first time you open up a Zim file, we cache the CSS and jQuery and things like that, so that subsequent reads from the network don't take as long. So as you can see, this is the Coffee Stack Exchange here. So I can go and click on a page like this, then it will load in. Up the top here, there's a dynamic search. So for instance, if this was a Wikipedia, you could just go in and type, and search Wikipedia as you would normally. And it would come up and you can browse through. So you can see here that the page popped in quite quick and you can already scroll through it and look at content. The one thing you'll notice is there's network activity still happening, and it's because the images are still loading in. So there you go. So the benefits of hosting Zim files in the Ceph network might not be apparent to begin with, but the Ceph network is permissionless in that you don't need permission from anyone to upload a file, and that once you upload a file, nobody can alter that file. So by hosting resources like Wikipedia on the Ceph network, you create this censorship-resistant quality to that data. So if anyone can access the Ceph network, they can access all of it. There's no way for a government, for example, to curate access to those resources. So in the case of Wikipedia, it's really important for people all around the world to have an uncensored access to educational content, and that's what Ceph Wiki brings. The whole reason we built this project was to analyse building applications on the Ceph network, and it was through building this application that we were then able to evaluate how good the Ceph network is for building applications.